The next method for solving quadratic equations that we're going to focus on is solving quadratic equations by the square root property. Reminder, we're going to let a, b, and c represent real numbers where a is not 0. And so a quadratic equation in the variable x is an equation of the form a times x squared plus b times x plus c. And because the degree of the equation where it is set equal to 0 is 2, the quadratic equation will always have two solutions. They could be real or they could be imaginary. And we're actually going to see an example today where our solutions are imaginary. To solve quadratic equations by using the square root property, we will recognize that if x squared is equal to k, where k is some constant, then x is equal to the square root of k, or x is equal to the negative of the square root of k. So that's where our two solutions come into play. So for example, we're going to solve this equation by using the square root property where x squared is equal to 100. Now because this is quadratic, I have two solutions, and that is because the degree of this equation is 2. So if x squared is equal to 100, I want to get rid of that square, and to undo a square, I use the square root. So the square root of x squared is equal to the positive or the negative square root of that constant 100. So the square root of x squared is simply x. And notice 100 is a perfect square, so the square root of 100 is 10. So our solutions are positive or negative 10. So the first solution is positive 10, and the second solution is negative 10. And doing real nice quick checks for this, 10 squared is equal to 100, but notice negative 10 squared is also equal to 100. So both of these solutions check. Question 1, you're going to solve by using the square root property x squared equals 81. Next example is more involved. We're going to solve by using the square root property 2 times x squared minus 14. So notice a is 2. B is 0. We have no term of x to the power of 1, do we? And then c is negative 14. So the first thing we have to take care of is we need our constant on the right-hand side of our equation. So we have 2 times x squared equals 14. Now remember, with the square root property, we need to get our variable squared alone. So we need to divide by 2. So that means x squared is equal to 14 divided by 2, or x squared equals 7. So now this is in proper form. To get x by itself, we're going to utilize square root. So square root of x squared is equal to, and this is the easiest thing to forget, this is quadratic. This has two solutions. So this is equal to positive or negative square root of 7. So x is equal to the square root of 7, or x is equal to negative square root of 7. So two solutions. And checking, we have 2 times the square root of 7 squared minus 14 is supposed to be equal to 0. Order of operations, square root of 7 squared is 7. And 2 times 7 is 14. and 14 minus 14 gives us a 0 and shows us that the square root of 7 is a solution. Now the next check is almost exactly the same. The only difference is inside our parentheses we have a negative. But remember, a negative squared is a positive. So this is going to give us 7 as well. And 2 times 7 is our 14. And 14 minus 14 is 0. So this shows that both the square root of 7 and the negative of the square root of 7 are solutions. Our third example, almost exactly the same as before. The major difference is we have plus 14. So we need to subtract to get our constant on the right-hand side. We need to divide by 2 to get our square term isolated and with a coefficient of 1. So that means x squared is equal to negative 14 divided by 2, which is negative 7. And now to get x by itself, we need to take the square root of x squared and the positive and negative square root of the constant. But our constant is negative, which means x is equal to positive or negative square root of negative 7. And anytime we have the square root or an even root of a negative, that means our solutions are imaginary, not real. And another way to write this is positive or negative I times the square root of 7. So we do have two solutions. It's I times the square root of 7 or negative I times the square root of 7. And we will not be checking imaginary solutions. Next example, you are going to solve this equation using the square root property. 3 times x squared minus 33 equals 0. Next example we'll tackle together. Solve the equation by using the square root property. This is our first time. Look at our quantity. We have not x by itself, but x plus 3. But that entire quantity is being squared. So we're going to undo the square by using the square root. So we have the square root of x plus 3 squared is equal to positive or negative square root of 100. So the square root undoes the square power and leaves us with x plus 3 plus or minus, and the square root of 100 is 10. And so now we have an extra step here as compared to what we've been doing. X is not alone, and so we need to get x alone by subtracting 3. And so x is equal to negative 3 plus or minus 10. And now we're going to separate. We're going to separate and then simplify. So x is equal to negative 3 plus 10, which means x is equal to 7. Or x is equal to negative 3 minus 10, which means x is equal to negative 13. And let's check both. So first, for x equals 7, 7 plus 3, quantity squared is supposed to equal 100. But literally 7 plus 3 is 10. And 10 squared is our 100, so this checks. And then our second check, negative 13 plus 3, quantity squared. But negative 13 plus 3 is negative 10. and a negative times a negative is a positive, and there's our 100. So both solutions check. For example 5, we're taking it again a step up. Similar to what we had for example 4, inside our parentheses, we have a binomial x minus 3. We need to undo that square power by using the square root. So the square root of x minus 3 squared is equal to positive or negative square root of 20. So the square root of x minus 3 squared leaves us with x minus 3. And then this is, again, a step up because 20 is not a perfect square, but it does contain a perfect square. What does 20 contain that is a perfect square? And hopefully you grasped onto the 4 with a 5. So we need to solve for x. So x is equal to 3 plus or minus, and the square root of 4 is 2, and the square root of 5 cannot be simplified any farther. So now separating, x is equal to 3 plus 2 square roots of 5, or x is equal to 3 minus 2 square roots of 5. And let's check. So if I look at 3 plus 2 square roots of 5, notice we have minus 3, and then that entire quantity is squared. But do you see that the 3's actually cancel, leaving us with 2 square roots of 5 squared? But 2 is being squared, which gives us 4. Radical 5 is being squared, which leaves us with 5, which results in 20. And the next check is almost exactly the same. Notice again the 3's cancel, leaving us with negative 2 times the square root of 5. But a negative squared is a positive. 2 squared is 4. Radical 5 squared is 5, which produces our desired 20. So both solutions are correct. So your job is to solve the equation by using the square root property of x plus 2 quantity squared, and this is set equal to 18. Make sure you recognize 18 is not a perfect square, but always take time and think about what does it contain.